In our next session, I would like to show you how to initialize interfaces of Firepower Threat Defense, and we will also take a look at the routing configuration. I'm gonna start with the device initialization, like when you deploy FTD for the first time, and you are supposed to select the interface modes and then possibly configure different types of interfaces, because as we will see, choosing the mode of the port, this is just one of the elements that you will have to think about. As we discussed in the previous session, this stuff is gonna eventually affect the behavior of the FTD, or just the function of the device, where the type of an interface, this stuff is related more of like to the physical and logical configuration of the port. Like on the ASA, FTD also supports high availability at the interface level. Now this is something that we can do with redundant interfaces or ether channels. Well, ether channel is only available on physical appliances. You will not be able to use this option on FTDV. Plus, we can also go for logical sub-interfaces. For example, when we want to use a single physical interface for multiple locations, logical segments of our network, and this stuff is going to be working along with 802.1q trunking, the same thing as on the ASA. Okay, deconfiguration is going to be performed from the devices tab, then device management and interfaces. We will go directly to the configuration. I will not discuss the differences between the redundant ports and different channels, because this stuff I already covered in the perimeter security section when we were talking about the ASA. So let's go ahead and take a look at the implementation. Now in our case, the FTD unit is connected to 3 different segments, and this is gonna make our outside over here. I'm gonna say that Giga 021, this is gonna be our inside, and finally a Giga 099, this is gonna be my DMZ. So as you can see, I will be using one physical interface, Gigabit Ethernet 0/0, and we will deploy FTD using sub interfaces, and this is gonna be example of firewall routed mode. Okay, so to start this configuration, we will have to select the unit. I have just one FTD that was previously registered with the FMC. And now the first thing that we will want to do here, now we will first want to enable the physical port. So I'm gonna go to interface gig 00, take a look at its settings. The first thing that you can choose from this list, as you can see here, is the mode. It shows passive, RSPAN, and none. When you choose none, it means that you want to use the firewall interface mode. So routed or bridged / transparent / switched, depending on the platform type that we are using. Okay, then I want to say that I will enable this port. So this is how I no shot. We will not be assigning it to a zone. I will not give it a name. This is not needed. I just want to no shot and click on OK. So the icon of this interface changed. Okay, next we will click on Add Interfaces, and I have 3 different options: sub-interface, redundant, and bridge grip. So if this was a physical appliance, you would also see ether channel option. We will just want to add some interfaces. I'm gonna click over here, and we will start with the inside port. It is gonna be enabled. It says choose a security zone. We haven't already defined any, so I will build a zone from here. The zone is gonna be called in. Okay, next I'm gonna select the physical port I wanna subdivide. I wanna logically break down into those virtual ports, Giga 0, and based on our topology, inside is over here, so it's gonna be VLAN 21. And then we will use VLAN 41 for the outside and VLAN 99 for the DMZ. subinterface number, identifier, and then static IP address 192.168.21.10/24. Note that we don't really have to use the regular network mask notation. We can go for the CIDR blocks, like here. Okay, then we will add another port for the outside. I'm also going to build a new security zone. Let's say out. So it automatically assigns this zone to this interface. Same physical port, a different VLAN, and different subnet, 172.141.10. So FTD is going to be using that 10 in all those three subnets. Okay, one more for the DMZ. And the zone is going to be called uppercase DMZ. Okay, I'm going to leave it as DM lowercase z. Then the interface, I will say the same. This is going to be the identifier, a VLAN number, and then the address is 192.168.19.10. Okay, obviously the physical interface GigaO that I use on this FTD unit, it is physically trunked to the switch, just to make it clear, like with any other type of sub-interface configuration. Okay, before we will see the effects of this configuration, I will have to click on Save on the FMC, and I will have to tell it to push this configuration to the FTD. So we still need to deploy this change. Select the unit, say deploy, and we will now take a look at the command line. Okay, those interfaces appear to be here. We will now take a look at the command line. If I were to use the regular default shell, we will say show interface IP brief. It generally takes some time for those changes to be pushed to show up on the sensor. Now, a better approach, like if you want to see this configuration faster, is going to be to switch the command line mode to the ASA or just Lina shell. I will say system support diagnostic CLI. This is how I get to the ASA prompt, and I can say show interface IP brief. Like here, I don't have to use the full command syntax. It's like on the ASA. In general, those changes will show up over here first and then on the default shell. We just have to wait for this to propagate. Okay, and we see that now they finally show up with the green status. It means that those ports are finally up. We synced this output with the FTD. One more thing I may want to do at this point is going to be to test connectivity in those segments. I will try to get router 4. This is my outside. Then on the inside, it is going to be router 2. And finally, the DMZ. The switch, I believe, is 12. 192.168. It's not going to be 21. It's going to be 99. Let me check the switch. Okay, the switch is not configured with the... Okay, let's do this. Let's say interface VLAN 99. Let's give it an address. Okay, now we have connectivity. Okay, so pretty simple stuff. All this config, at least for the sub interfaces, is done from the interfaces tab. If you wanted to deal with next generation IPS interfaces, inline ones, you would have to build the inline sets. Okay, but we will not be doing this in that session. Now, to finish the basic configuration, basic setup of the FTD, we will also take a look at routing configuration. The routing implementation of FTD is very similar to what we have on the ASA. Things like the concept of admin distance metrics, static routes, also route processing, routing table. This is going to be the same thing as what we have on the ASA. From the configuration standpoint, the only thing that is going to be different on FTD, comparing it to the ASA, is going to be the GUI that you use to make the config changes. Okay, now in terms of the actual protocols that are supported as of 6.2, we can go for OSPF for IP version 4 and IP version 6. We can do the same for BGP. We can use RIP with IP version 4, but EIGRP is, as of the current code, not supported via the GUI. You can still, however, use it using the so-called flex config feature. What is flex config? Flex config is just a method of adding the currently unsupported features to the FTD for a special script, which is based on the regular ASA CLI syntax. In other words, you can use the ASA syntax to come up with a text file and then upload this text file for the special flex config window on the FMC, and then push this configuration to the FTD, and many of the features that are currently not available on the FMC you will be able to activate on the FTD. But this is deemed as a more of like an advanced task, and we will not be looking at it. We will just focus on OSPF. Okay, from the same path, devices and device management, we'll just change the tab. We will say routing. And this is where I'm going to enable OSPF. We have OSPF version 2, OSPF v3, RIP for IP version 4, then BGP, and also static routing and possibly multicast routing. Multicast is also supported in the routed mode. Okay, so we are with the OSPF tab. I'm going to enable OSPF process. This is going to be process number 1. Our FTD is going to act as a regular device. It will not be an ABR, ASBR, or maybe both. It is going to act as a regular device in an area. And then from the area tab, we'll just add the area configuration. So I'm going to put all devices on the backbone to the backbone area. For process number 1, it is going to be a regular area. It is not going to be a stop or an SSA. And now from the available network section, this is where I tell it what interfaces I want to enable the process on. So this is an equivalent of the network command on iOS. You can add objects from here, like add an object for the inside, add an object for the outside, another one for the DMZ. But what I will do instead, since I'm going to assume that we will want to enable OSPF on all interfaces over here, here, and here, I will simply say that I want to run OSPF on all IPs. This is the default route. So enable OSPF everywhere. Now, if you wanted to do some more advanced config, like possibly redistribute routes between the different routing domains, or maybe play with OSPF, summarization, filtering, interface settings, you would be using those tabs. It's pretty self-explanatory stuff. So those GUIs are generally pretty easy to follow, and as long as you know how the routing protocol works, how to enable it on iOS or the ASA, you will be able to use those different options, find those different options here pretty quickly. I'm gonna say save, and we have to deploy this configuration. Just actually, one more thing that I want to check. I think I said I want to enable the process in the backbone. Okay, I did that. Because I have the routers pre-configured and they are all part of the backbone. So in order to form adjacency, we will have to also put those interfaces into the backbone area. Okay, push the changes. As in the previous case, it is going to take a while for FMC to deliver this configuration to the FTD unit. I'm going to say show route OSPF. Okay, nothing here. Let's also say show OSPF interface brief. So we'll have to wait until it pushes this configuration. Okay, it looks like OSPF was enabled on those interfaces. So OSPF neighbor. We built the adjacency with these two devices, router 2 and router 4 over here. So this is my backbone. Switch is not configured for OSPF, so we will not see an adjacency here, but we will still advertise this segment on the FTD. So when I now say show route on the FTD, you will see a default route advertised by 4. We see a route advertised by 2, and this is another subnet advertised by 4. Just to finish this configuration, I will try to ping those remote subnets, like get to router 4, and then router 2. Maybe let's also take router 2, show IP route OSPF. We are getting the prefixes, we are getting the DMZ from the FTD unit.